Today we will be looking at time as the fourth dimension. We will be working from the beginning to help build our understanding. Now keep in mind that this is a simplification and is just to help get an idea of the fourth dimension. This is in no way a professional mathematical explanation, just how I interpret it. First, we start with 0 dimensions. This is just a point in space. In this state, we do not have any context. There is no way to compare it with something else. But it is a start to many more things. If we get many of these points, we create a line segment. If we continuously place points, it would be infinitely long. Pretend that this visual is 0 width. This is just an illustration. We can even label these points with numbers. For example, the natural numbers. We can compare points at this stage because we can have numbers left or right of each other. Now if we were to take a slice of this one-dimensional thing, we would simply have a dot. This is the x-axis. If we turn 90 degrees and stack more of these lines we made, we would get a rectangle. Various other shapes exist, but for this illustration, we'll ignore it. This is a two-dimensional shape. It had a length and width. Not only can we compare 2 points, but we can do so with a bit more options. We can see two-dimensional shapes being used in graphs and charts because we have a system to plot points. If we take a slice or cross-section, we would have a line. This is the y-axis. If we turn 90 degrees again but in a different direction and stack these rectangles, we enter the third dimension. This dimension we are the most familiar with as we live in it. These have length, width, and depth. These are also used as graphs, but we can more commonly find them as a box. If we take a cross-section of this, it would result in the rectangle. This is the z-axis. Now when we look at the fourth dimension, we must acknowledge some patterns. A cross-section of a higher dimension results in a similar shape or style. For example, a cross-section of a sphere, which is 3D, results in an ellipse or circle, which is 2D. A cross-section of a rectangular prism, which is 3D, results in a rectangle, which is 2D. A fourth-dimensional object would be composed of 3D objects put together, with time being the fourth axis that, so to say, cycles through each one. A comparison, I like to make it to a 3D zoetrope. We have all these parts that make one thing, but in order to see a quote animation unquote. Here are some examples of that. There is a start and end. Or it could even loop. This 3D printed zoetrope is the best one I found that fits what I understand. I will link the video below.